Hello there. Today we will start with Unit 3 of this course. We are at Lesson 1 of this unit. This unit is all about flowcharts. The objective of this lesson is to get a firm idea about flowcharts. As the name says, it is a chart that shows the flow of a task or a program. We will start with what is a flowchart, how does it look like? What are the various features of a flowchart? How is the flow of program shown in a flowchart? We will look at some basic symbols used in making flowcharts and some examples of the same. So here we go. We did pseudocodes in the previous unit. A pseudocode is a text-based representation of an algorithm. It is written in natural language, which at most of the times is English. On the other hand, a flowchart is a pictorial representation of an algorithm. It is the diagram of step-by-step solution to a given problem. A flowchart generally shows flow of data in a program. Each step in the flowchart is represented by a box-like symbol of different shapes, and they are linked together with arrows. It clearly shows the sequence in which the steps are performed to solve a given problem. Just like an architect draws a map or a blueprint for a house before starting the actual construction of the house, a programmer first draws a flowchart of the problem before writing the actual program. A flowchart is drawn, but the instructions in the boxes are written in simple language, without using any specific programming language syntax, so it is easy to understand and follow. Here we list down some features of the flowcharts. A flowchart, like a pseudocode, has a well-defined start and end point. We draw flowcharts by drawing boxes of different shapes and writing the program instructions inside that box. We will see later what different shaped boxes are meant for. We connect the boxes to each other by arrows drawn in the direction of program flow. A flowchart can be drawn on a paper by hand, or we can also use software tools for it, such as the MS Word and MS PowerPoint have special flowcharting tools and symbols. There are other software programs also available, like the eDraw, Visual Logic, etc. Like a pseudocode, the instructions in flowchart also use some common keywords, symbols, and operators, like the mathematical operators, which are used most commonly. As a beginner who is learning to program, it is a good idea to draw a flowchart before writing a program to understand the sequence and flow of the logic. Since it is a picture form of a program, it is easy to spot any errors or mistakes or any points which are missed out. A diagram is often easy to explain to a non-programmer as well. So in a programming project, flowcharts facilitate communication between programmers and non-programmers or the project management people. So here is the first quiz of this lesson. A flowchart is the dash view of the program flow. What is the answer? The answer is, a flowchart is the pictorial or graphical view of the program flow. Another quiz for you. This one is super easy. Boxes in a flowchart are connected by, and the answer is arrows. Boxes in a flowchart are connected by an arrow. Another question for you. In a flowchart, instructions are written inside or outside the boxes. Which one is true? The answer is, the instructions are written inside the boxes. There are some standard symbols used to draw a flowchart. The flowchart begins and ends with an oval box. We place the start and end keywords in the oval boxes. They depict the beginning and the end of a flowchart. The instructions inside the boxes is written in English generally. The parallelogram shape represents any input taken in the program or any output produced by the program. Both input and output use this box symbol with keywords like read, input, enter for input operations and print, display or output for output operations. Input for the program is followed by some processing of data that is entered. The processing part is written in a rectangle box. Any data manipulations or mathematical operations take place inside a rectangle box. Now sometimes the steps in the program depend on a decision to be taken. If yes, then do this. If no, then do something else. Similar to the if then else statement that we used in the pseudocode. So the decision part is written in a diamond-shaped box. Depending on the outcome of the decision, whether it is yes or no, the next step in the flowchart is executed. As we mentioned earlier, the box statements in the flowchart are linked by arrows. The direction of the arrow tells us which way the data is flowing. Which step is the next one to execute? Do you know that you can draw flowcharts for your everyday tasks too? Try doing it. It will be fun. Let's draw some funny but amazing flowcharts first to give you an idea of how a flowchart looks like and how it can be applied to solve just any problem. Everyday tasks that we see and do can be very well represented in the form of a flowchart. Here's a look at that. Now a question pops up in the mind of a student. When should I do my homework? Children dread doing homework and avoid it till the last minute. Till it is the last minute now. Do it. So here's this scenario depicted in a flowchart. Let's go through it once. We write the start statement in the oval box. The next step, we check the diary notes. Because this is a process or some action taking place, so we write that in a rectangle box. So we check the diary notes. Then we have a decision to make. Do you have homework? And we write that decision in a diamond box. If no, then hooray, you can play soccer the whole time. And the flowchart goes to a stop. But if yes, you have a homework, then another question pops up in your mind. Do you have to submit it tomorrow? Well, if no, then you can do it tomorrow also, and the flowchart comes to an end. But what if you have to submit it tomorrow? Then you have to follow the arrow saying yes. And it says start doing it right away. And the flowchart comes to an end. All the statements of the flowchart culminate to a stop. It is essential to complete the flow of the flowchart, which means you have to place an end or a stop statement to signify that your flowchart has ended. Another task in the everyday life of a student is to get up in the morning and go to school. Let's see this in the form of flowchart. We start the flowchart by an oval box and write the start statement inside it. Then the next step would be to get up and get ready. Now you ask a question to yourself, is your school bag ready? If no, then you have to pack your bag then. Then you can have your breakfast. Well, if your school box is ready, you can follow the yes arrow. You can have your breakfast and the next step is to board your school bus, or if you ride your bike to school, take it. And the flowchart comes to a stop. Another one for you. Imagine your mom and dad are not at home and you are feeling hungry. Now how do you deal with your hunger? A good task to make a flowchart for. So we write the start in the oval box to start the flowchart. Then the next would be a process box. You check for food in the refrigerator and ask a question. Is there something to eat in the refrigerator? Now this has two possible outcomes, yes and no. If you have something to eat in the refrigerator, then follow the yes arrow and then enjoy your food and the flowchart comes to a stop. But let's say no, there's nothing to eat in the refrigerator. So the next question pops up, can you cook for yourself? Now this has two options, yes or no. If you cannot cook for yourself, then you follow the arrow that says no. You order a takeaway meal. When the meal comes, you enjoy your food and the flowchart comes to an end. Let's say you can cook for yourself. Then you follow the arrow that says yes and start cooking. After cooking, the next step would be to enjoy your food and the last step would be stop. So the flowchart will come to an end. So you see, they are easy to follow if all steps are written in sequence. Just follow the direction of the arrows for your next step. Please note that your flowchart may differ from this one or any other flowchart for the same task. But that is okay till you have identified and mentioned all the steps in correct order. Try picking up a situation from your everyday life and draw a flowchart for it. Now let's get some real action here. We see some real programming tasks in the term of a flowchart. This one calculates the percentage marks of a student who appeared in a test for 5 subjects. Let's go through this once. We start the flowchart by writing the start statement in the oval box. Then we need the input for this flowchart, so we write it in a parallelogram. We input the marks for 5 subjects in M1, M2, M3, M4, M5 variables. The next step would be to calculate the total of these marks for 5 subjects. So it's a processing part which is written in a rectangle box. So the total will become M1 plus M2 plus M3 plus M4 plus M5. So now the total holds the marks scored in 5 subjects. To calculate the percentage marks, which is another processing step, so it is written in a rectangle, it is calculated as the total marks divided by the highest score for the subjects multiplied by 100. The next step would be to output the percentage marks. And as similar to input, the output also uses the parallelogram shaped box. So the output, that is the percentage marks, is displayed to the user. And the stop statement ends the flowchart. Let's have a look at it with the help of an example. Let's say the marks entered by the user are 20, 15, 18, 12 and 18. These are the marks for the 5 subjects which get stored in M1, M2, M3, M4 and M5 respectively. We are assuming that these marks are scored out of 20 each. Next, we calculate the total of these marks. We simply add up them and the total comes to 83. Next, we calculate the percentage marks, which is 83 divided by 100 multiplied by 100. So we get the percentage as 83%. This flowchart shows a simple sequential flow with no conditions or loops. It seems easy to read. Well, this flowchart calculates the volume of a cuboid. The volume of a cuboid is length times breadth times height. So the user inputs the length, breadth and height of a cuboid which gets stored in the variables L, B and H. So next step would be the calculation of volume, which is a processing part, so written in a rectangle. The volume of a cuboid is length time breadth time height. And next step would be to output the volume, which is written in a parallelogram, and the flowchart comes to a stop. For example, the user enters these dimensions for the cuboid: 10 cm, 6 cm and 4 cm. These values get stored in L, B and H respectively. Next, the volume of the cuboid is calculated, which is 10 times 6 times 4. and it comes out to be 240 cm cube. So this is the volume of cuboid, and the flowchart comes to an end. So here we end this lesson. Do download and try out some exercises that will test your knowledge on the topics covered here. We see you soon at the next lesson.